Hello everyone, I am Abhilashim, working as Assistant Professor at Department of Mechanical Engineering, MIT, Mysore. Today, I am here to discuss a session of the subject Elements of Mechanical Engineering. Under that, we are going to discuss Module 4, which is all about Mechanical Power Transmission and Joining Process. In that particularly, I am going to discuss the concept with respect to the joining processes. So before proceeding for joining processes, we should understand what is a joining. We all have heard the term called as joining, right? It is all about combining two or more individual items in order to obtain a single item or a single component. So joining two or more individual components in order to obtain a single component, we are going to call it as a joining. But in mechanical engineering, under manufacturing sector, we are going to join two or more materials in order to obtain an uniform or homogeneous joint. For example, let us take an example of our automobile itself. Under automobile, we can see many individual components which are joined together in order to obtain an uniform component. Similarly, any building structures or any components that you look around will be based on a joining process itself. So we have understood what is this particular joining. So joining is nothing but combining an individual component in order to obtain an homogeneous component of desired size and shape, we can say. So under the joining processes, the process that is used in order to join two or more components, we are going to call it as a joining processes. Under joining process, we have two broad classification. The first one is called as temporary joining. It is called as what? Temporary joining. So under temporary joining, the components that are joined can be dismantled or they can be removed whenever it is required. For example, imagine you join two components with the help of a nut and bolt. That nut and bolt can be removed whenever it is required and you can make them as an individual component, is it not? So where all we make use of this nut and bolts, studs, fasteners, we can call the type of joint as a temporary joint. So the examples for the temporary joints are nut and bolt, fasteners, and even studs that we make use in the mechanical industries are good examples for a temporary joint or temporary joining process. So the name itself is suggesting it is temporary. I can remove or I can remove the components whenever it is required and I can join back them whenever it is required in order to make it as a single component. Similarly, the other type of joining process is called as a permanent joining. The name itself is suggesting permanent joining. Under permanent joining, once if the components are joined together, they cannot be dismantled whenever it is required. So your automobile structure itself, we can see many parts that have been welded. They cannot be dismantled very easily. They cannot be disassembled very easily. So that joints we call it as a permanent joints. The very basic and a good example in order to understand the permanent joining is all about welding. So welding is a classical example in order to understand the permanent joining. So under joining process in manufacturing sector, we categorize them into two. One is called as a temporary joining, the other one is called as a permanent joining. Under temporary joining, the two individual components that you are going to join can be disassembled or assembled whenever it is required. And under permanent joining, once you have joined it, you cannot dismantle very easily. So this is all about joining process. But under joining process in the subject of elements of mechanical engineering, we are going to learn three predominant topics that are very essential in the mechanical sector. The three important components or the three important process under mechanical industries are, the very first and the basic one is called as a welding. So apart from welding, we are going to learn other two concepts that are called as a soldering and the brazing processes, that we'll discuss later. But what is this welding? We all have seen welding in our day-to-day life while traveling. We might have seen in any workshops or even the fabrication work for our house constructions. We have seen this particular welding process happening, whether in order to make the gates of our houses or the window frames. All those we are going to see this particular welding that has been taking place. So what is this welding is all about? So as I mentioned, it's a permanent joining process. So under joining process, we are going to learn only with respect to the permanent join. Under that, we are going to first learn the concept with respect to the welding. So what is this welding? A basic definition with respect to the welding is such that welding is a joining process where two components are joined with the help of heat in order to obtain an homogeneous component. So the two different individual components are joined with the help of heat in order to produce an homogeneous joint or an individual joint. So this is a basic definition with respect to the welding. But actually, how do we define welding is, it's a metallurgical process. So welding is a metallurgical process of joining two similar or dissimilar metals. Two similar or dissimilar metals by the application of heat. Heat is very essential. By the application of heat with or without application of filler material. So we'll come to know this. What is this filler material? So with or without filler material and with or without application of pressure. So with or without application of force or pressure in order to produce an homogeneous joint. In order to produce an homogeneous joint. So how can I define this particular welding process? It's a metallurgical process. We are going to change the structure of a materials. So it's a metallurgical process of joining two similar or dissimilar materials by the application of heat. Heat is very much essential in order to join two pieces. With or without the application of a filler material, with or without the application of a force or pressure in order to produce what? A homogeneous joint. So in order to just explain you in detail, see these two are the base metals that I require to join. Imagine. So I need to produce an homogeneous joint. So what I am going to do is, I am going to choose from the variety of welding types that are available, and I am going to join these two materials, these two metal pieces in order to produce a homogeneous joint with this in this of nature. So the two individual metal components has been joined by the application of heat with or without application of a pressure, with or without application of a filler material in order to produce an homogeneous joint. So this is with respect to the definition with respect to the welding. But welding classification we are going to learn now. So what is this, or how exactly the welding has been classified? This welding is broadly classified into two different types. The welding process is classified into two different types, under which the very first one is called as pressure welding. Pressure welding, or it is also called as plastic welding. We call it as either pressure welding or we call them as the plastic welding. What is this plastic welding or pressure welding? The name itself is suggesting we are going to apply the pressure in order to produce an homogeneous joint. Here the material that are to be joined are heated only up to the plastic state. Then with the help of an external force or pressure we are going to join them. No filler material will be used. these two materials that I am going to join will be heated up to the plastic state of this particular material. Imagine this is a mild steel having a melting temperature of about 1400 to 1600 degrees Celsius. We are not going to heat up to the melting point. We are going to heat up to the base of the metal, only up to the plastic state. And then with the help of an external force or pressure, I am going to join these two individual components in order to obtain an homogeneous joint. So that type of welding we are going to call it as what? A pressure welding. So under pressure welding we have two different types. The one is called as a forge welding. Forge welding. The other one is called as resistance welding. The other one is called as a resistance welding. The other type of welding process we are going to call it as a fusion welding. So the first one is called as a pressure welding. The other one is called as a fusion welding, or it is also called as non-pressure welding. We are not going to apply the pressure. We are going to heat the material up to its molten state, and then with the help of a filler material we are going to allow the material to cool in order to solidify and then produce an joint. So here we are going to heat up to the plastic state, but here we are going to heat it completely up to the molten state of both the base metal, and then with the help of additional filler material I am going to allow that filler material in order to pass through the gap that we have created, and when you allow them to cool you are going to obtain an homogeneous joint. So this is called as a fusion welding. Under fusion welding we have different types, but in our syllabus we are going to learn the concept with respect to the arc welding. Arc welding, and then we have thermite welding. We have arc welding, thermite welding, and then gas welding. So these three comes under the fusion welding process, where we are going to heat the material up to the molten state, and then with the help of a filler material we are going to allow the filler material to occupy the gap in between the two work pieces, and then when you allow it to solidify you are going to obtain an homogeneous joint. So this is with respect to the classification under welding. We have the pressure welding, fusion welding, heated up to the plastic region, heated up to the molten state. And then the good examples for the pressure welding or the plastic welding are the forge welding and the resistance welding, and for the fusion welding the examples are the arc welding, thermite welding as well as the gas welding. And always remember that the welding process that we see in the fabrication works will be generally in the order of the arc welding or the gas welding, what we look around. Then when it comes for a railway tracks joining process, and then they are going to make use of a thermite welding process. Whatever the welding process you are going to choose, but one parameter is very essential, that is the heat. How you are going to produce the heat is the question. For example, in the case of an arc welding, we are going to make use of an electric arc in order to convert the electrical energy into the heat energy and then do the process. Under gas welding, we are going to make use of a strong gas flames in order to produce the heat in order to melt the base metal. And then under the resistance welding, we are going to make use of an electric current, the resistance offered by the electric currents in order to produce the heat, so that when you apply the force or pressure, the base metals will get joined in order to produce an homogeneous joint. So as I mentioned earlier, the welding can be found their applications in the construction works, in machineries, in all other fields. Okay, so in the next session we are going to learn the concept with respect to the first fusion welding process, that is the arc welding. So now let us learn the concept with respect to the arc welding. Now let us learn the concepts of welding through the process. So far we have learnt what is joining process, how the joining process is classified, that is temporary and permanent, Under permanent, we have taken example of welding. So under welding, we have seen two different types of welding. One is called pressure welding, the other one is called as fusion welding. So we know the difference as well now. So now let us take the first welding process, which is an electric arc welding process. See, this electric arc welding comes under a heading called as an arc welding process. During the examples of fusion welding, we have taken examples as arc welding, gas welding, thermite welding, so far. Okay. So under the arc welding, the first process that we are going to learn is called as an electric arc welding. The name itself is suggesting that we are going to make use of an electrical energy to be converted into the heat energy, under which we are going to complete the process of joining through the arc welding process. So what is this arc welding? Basically, an electric arc welding is a fusion welding process. What type of welding it is? It's a fusion welding process in which a high intensity of arc, that is generated during the process is utilized in order to melt the surface of the workpiece. So basically, an electric arc welding is a fusion welding process in which a high intensity of arc which is generated during the process is utilized in order to melt the surface of the workpiece. On what principle this electric arc welding works? So let us try to learn the principle on which this electric arc welding works. We know that when two conductors are met, they form an electric circuit. The simple principle has been used here. See, when the two conductors of an electric circuit are touched together, there will be a flow of an electric current through that particular circuit. So the same concept is applied here. The two conductors are going to meet, but when they meet, they are going to be separated by maintaining a gap of about 2 to 4 millimeter, which will lead for the establishment of an arc, which is nothing but the electrical energy gets converted into the heat energy. So when two conductors of an electric circuit are touched together momentarily and they are separated by maintaining a gap of about 2 to 4 millimeter, an electric arc is formed. You should ensure that there is sufficient voltage between the flow of the current. So if you maintain a sufficient voltage and when you touch together momentarily and when you separate by maintaining a gap of about 2 to 4 millimeter, an electric arc will be produced, which will be having a used temperature of about 5000 to 6000 degrees Celsius, which is sufficient enough in order to melt any base material. So that heat energy is utilized in order to melt the surface of the workpiece. Now, if we come by understanding the definition as well as the principle, let us directly move for the working principle of an electric arc welding through a schematic diagram. So before coming for this actual process, let us try to learn what are the components that are present in the electric arc welding process, or which are the components that are required for this particular process. See, the first thing is we require two workpieces that need to be joined. These two workpiece surfaces will be thoroughly cleaned first and they will be placed on a work table. This work table will be connected for the positive terminal of the power supply, whereas the negative terminal is connected for the electrode holder which holds the electrode. What is this electrode? See, this electrode is the filler material which will occupy the gap in between the two workpieces in order to form an homogeneous joint. See, in the definition we understood that under pressure welding we are going to heat the material up to the plastic state. With the help of an external pressure we are going to allow both the material to get joined. Whereas in the case of fusion welding, we are going to make use of an additional material which is called as a filler material in order to fill the gap in between the two workpieces. In this case, the electrode will be used as an filler material in the case of an arc welding. What is this electrode? What are its type? See, basically electrode is a filler material which is used during the arc welding process. It's a filler material. There are two types of electrode which are generally used. First one is called as the consumable electrode. Consumable electrode. The name itself is suggesting consumable electrode. This electrode will be consumed during the process, or they will melt during the process and they will occupy the gap in between the two workpieces. Under consumable electrode, we have two different categories. The first one is called as coated electrode. Coated consumable electrode. What is this coated electrode? The electrodes, the consumable electrodes, are generally coated with some flux materials. Why this is required? In order to avoid the oxidation that will take place during the process if it is not protected. If this arc is not protected, the molten metal will get exposed in the atmosphere, they will absorb the oxygen and they form a joint which are of weaker section. So we want a homogeneous joint which is stronger. So in order to ensure that the joints are stronger, we are supposed to go ahead with the coated electrode. There is other type of electrode, consumable electrode as well, which is a bare electrode, which will just melt and occupy in between the gap between the two workpieces. So under consumable electrode, we have two different types. One is called as a coated electrode, the other one is called as a bare electrode. What is the other type of electrode is the non-consumable electrode. Non-consumable electrode. The good example for this is a tungsten electrode, which is of non-consumable because the melting point of a tungsten is really high, so they won't get consumed during the process. They are just used in order to produce the arc, which is essential for the electric arc welding process. So under electrodes, we have understood that basically electrodes are the filler material. There are two types. One is called as a consumable electrode, the other one is called as a non-consumable electrode. Under consumable electrode, we have two categories. One is called a coated electrode, the other one is a bare electrode. Coated electrode, they are protected with the flux coating around the electrode to ensure that no oxidation process takes place during the process and the same arc length is maintained throughout the process. And we have the other type as a bare electrode, which with the help of this, if you form the welding joints, they will be of weaker section. The other one is a non-consumable electrode, where the electrodes are not consumed during the process. Now we were discussing with respect to the electrodes and the electrode holder. Now during the process, what will happen? We have understood the basic components that are with respect to the electric arc welding. It will consist of two materials that needs to be joined, and they are placed on a work table that will be connected for the positive terminal of the power supply. Next, the negative terminal will be connected for the electrode holder, which holds the electrode. What type of electrode we are going to make use of? We are going to make use of a coated electrode during this process. Now how exactly the operation, or what happens during the operation process of the electric arc welding? When this particular electrode comes in contact with the workpiece table or the work table, there is an electric circuit which is established continuously, but we are not going to keep this in contact. What we are going to do? We are going to touch them and momentarily separate them by maintaining a gap of about 2 to 4 millimeter, such that a high intensity of electric arc is generated, which is sufficient enough in order to melt the surface of the base material. During this process, even the electrode will also start to melt, and it will occupy the gap in between the two workpieces, and when you allow them to cool or solidify, you are going to obtain an homogeneous joint. So you are supposed to complete the process, and when you allow them to cool, you are going to obtain an homogeneous joint. This is the slag that is formed after the process. Okay, so during the process, you are going to make the electric arc to pass from one length to the other length, and the filler material will occupy the gap in between the two workpieces, and when you allow them to cool, you are going to obtain an homogeneous joint. Well, this is how an electric arc welding process is going to work. Now let us try to learn the concept with respect to the gas welding. Now let us try to learn the next fusion welding process, that is all about gas welding. The name itself is suggesting a strong gas flame is used in order to raise the temperature of the surface of the workpieces, and then in order to produce an homogeneous joint. The different type of gas mixtures that can be used in order to produce the gas flame are, the first one is either we can make use of oxygen acetylene mixture, or the other combination is oxygen hydrogen mixture. So basically, gas welding is a fusion welding process in which a strong gas flame is used in order to raise the temperature of the base metal in order to obtain an homogeneous joint. And then filler material will be used in order to fill the gap between the two workpiece surfaces. The different mixture of gases that can be used in order to obtain the flames are either it could be the oxygen acetylene mixture or the oxygen hydrogen mixture. Now a typical representation of the gas welding process is here, and we are going to learn the concept with respect to the oxygen acetylene mixture. So now the sketch what we have written is with respect to the oxygen acetylene gas welding process. Now what does it consist of, or what are the components of an oxygen acetylene gas welding, or oxyacetylene we generally call it as. So oxyacetylene gas welding process. So it consists of two large steel cylinders. One is consisting of oxygen, the other one is consisting of acetylene mixture. So two individual steel cylinders, one comprising of oxygen, the other one consisting of acetylene. Both are regulated with the help of a pressure regulators. The pressure regulators are used in order to regulate the pressure of these two cylinders, that is the oxygen and the acetylene cylinder. A flexible hoses or pipes are used in order to supply the mixture of oxygen and acetylene into the chamber called as a torch. So we have a gas control valve in order to regulate the flow of gases. We have a torch in which both the gases are going to mixed. So we have a mixing chamber where both the gases will be mixed in equal proportions, and at the tip of the torch that mixture of gases will be ignited in order to obtain the gas flame. And that flame will be generally of 3200 degrees Celsius, which is sufficient enough in order to melt the surface of any commercially available materials. So this is with respect to the components that we are going to make use in the case of the gas welding. And as I mentioned, we are going to make use of this particular filler rod, an additional filler material which occupies the gap in between the two workpieces. In the case of electric arc welding, we are not going to make use of an additional filler material. The electrode itself will act as a filler material. So to begin with, how exactly the process is going to done. So initially the mixture of gases from both oxygen and acetylene gases will be supplied into the welding torch, where they get mixed in the mixing chamber, and that mixed gas will be ignited at the torch tip, where it produces a strong gas flame. The base material that needs to be joined are cleaned and positioned on a particular table, and when the flame is obtained, that flame is sufficient high. It will be having a temperature of about 3200 degrees Celsius in order to melt the surface of the workpieces that needs to be joined. Meantime, the filler material will also come in contact with the strong gas flame, where they get melted and they fill the gap in between the two surfaces of the workpieces, and when you allow them to cool, you are going to obtain an uniform joint. So this is a simple process. We have both the cylinders consisting of oxygen and acetylene. These gases will be sent into the mixing chamber with the help of a flexible hoses, and when they get mixed, they are going to get ignited at the torch tip and a strong gas flame will be produced, and that flame is sufficient enough in order to melt the surface of the workpieces. Meantime, the filler rod will also start to melt and it will occupy the gap in between the two surfaces of the workpiece, and when you allow it to cool, you are going to obtain an homogeneous joint. Sir, how the flame is going to look like? Because we are combining the mixture of oxygen and acetylene, how exactly the flame is going to look like? There are three different flames that we are going to obtain by varying the proportion of mixture of gases. The very first is called as a neutral flame. The neutral flame is obtained by supplying equal quantity of both oxygen and acetylene. When we supply 1:1 ratio of oxygen and acetylene, we are going to obtain a type of flame called as a neutral flame. What does that neutral flame consist of? It consists of an inner white cone. It consists of an inner white cone surrounded by blue envelope, the outer blue envelope. Now this is how the neutral flame is going to look like. It will have two cones. One is an inner white cone surrounded by an outer blue envelope. Very normally, oxyacetylene welding is preferred with the help of a neutral flame. So we know what is a neutral flame. The neutral flame is by supplying equal quantity of oxygen and acetylene, we are going to obtain the flame at the tip of the torch, and that is called as a neutral flame. What does it consist of? It consists of an inner white cone surrounded by an outer blue envelope. Sir, what if I increase the acetylene percentage? Or what if you increase the oxygen percentage, vice versa? So we are going to obtain two different type of flames. The one is first increasing the supply of acetylene. More acetylene, less oxygen. More acetylene and less oxygen. The type of flame that we are going to obtain is called as an carburizing flame, or it is also called as a reducing flame. So this reducing flame or carburizing flame consisting of three different cones: inner cone, intermediate feather cone, followed by an outer blue envelope. So there are three different cones that are obtained when it is with respect to the carburizing or reducing flame. This type of flame is preferred when we are welding for non-ferrous alloy materials. Whenever we go ahead with the non-ferrous materials, we are going to take the type of flame as a carburizing or a reducing flame. And what does it consist of? It consists of three different type cones. How do I differentiate is by supplying an excess acetylene, I can obtain this particular reducing flame, which consists of inner white cone, intermediate feather surrounded by an outer blue envelope. The last type of a flame that we are going to obtain by supplying excess oxygen, less acetylene. This is not preferred one. Generally we avoid, because more oxygen means it leads for the oxidation. So how the cone or how the flame is going to look like? It looks very similar to the neutral flame, but the only thing is the inner white cone is of shorter in length compared to that of a neutral flame. So the difference between an oxidizing and a neutral flame is such that both will have two cones, but the inner cone will be of shorter length when compared to that of a neutral flame. And how do I obtain the oxidizing flame? The oxidizing flame is obtained by supplying excess oxygen and less acetylene. So by varying the proportions of the oxygen and acetylene, I can obtain three different type of flames, and they are One is neutral flame, equal quantity of oxygen and acetylene. The carburizing or reducing flame, more acetylene, less oxygen, preferred for non-ferrous metals. The oxidizing flame, which is obtained by supplying excess oxygen and less acetylene. So this is with respect to the process of gas welding, which is once again a fusion welding process in which a strong gas flame is used in order to raise the temperature of a base metal and ensure that we are going to make use of an additional filler material in order to fill the gap in between the two surfaces of the workpiece. Thank you.